Now we're going to look at a max-min question. In this question, we're finding the maximum height of a ball thrown in the air. Key word is maximum. This means we will be completing the square because we want that vertex. Over here, I'm drawing the ball's pattern in the air. We can see that the y-intercept there is 3, and the maximum height happens at its vertex. It forms a parabola. So first thing we're going to do is rearrange this formula into the form ax squared plus bx plus c. The c value, the 3, is the initial height, and 14 represents the velocity. To start the process of completing the square, we factor out the a value out of the first two terms only. So we divide out that -5 and we're left with t squared minus 2.8t. Next, we look at this b value and we take it, divide it by 2, and then square it, getting that special value. Now, we take the -5, t squared minus 2.8t, and then we add that special value, and then subtract it as if it never happened. Close that bracket and add the 3 to the end. Now, the goal here is to get rid of that last term. To get it out of the bracket, we need to multiply it by the a value in front. So we're left with t squared minus 2.8t plus 1.96, and when we multiply those two terms, we end up with a positive 9.8. So inside of our bracket, we are left with a perfect square trinomial, which is what we created. So in order to factor this, we take the square root of the first term, we use the first sign given, which is the subtraction sign, and we take the square root of the last term, or half of the b term, which is 1.4. And then we add the 9.8 and the 3 to the end, getting our maximum height. 12.8 is our maximum height. And when does that happen? It happens when t equals 1.4 seconds. Now we're going to look at the example of when the ball hits the ground. That means that we set h to equal 0, and we will be isolating for the t value, which represents the time at which it hits the ground. So in this example, we're going to use the quadratic formula right there on the right. So we fill in all of our values, the b, the a, the c, and we solve it. So we've got -14 plus or minus the square root of 14, which is 196, plus 60 over -10. Now we're going to solve underneath the root sign. -14 plus or minus 256 all over -10. Now we can solve the square root of 256, which is 16. So now that we have that plus and minus, we can break it up into two different values of t, or x. -14 plus 16 over -10, and x equals -14 minus 16 over -10. And you'll see the two different values of the t, which makes sense. Because it's a parabola, it hits that x-intercept twice. So we have x equals 2 over -10, which equals -0.2, which doesn't make any sense. Doesn't make sense to have negative time, so we ignore it. And the last one is x equals -14 minus 16 over -10, which is -30 over -10, equaling 3 seconds. The graph here demonstrates those x's that we just found, where it lies at -0.2, and it goes up in the air and lands back down after 3 seconds. Using the same example, only this time we're going to find out when the ball hits my friend's hands 3 feet above the ground. So instead of the ball reaching the ground and h equaling 0, we're actually going to move that y-axis up to 3, because that's where the ball will be landing now. So we're going to have h equal the 3 feet. So my equation looks like this. 3 equals negative 5t squared plus 14t plus 3. Now we want this equation to equal 0, so we take that 3 and bring it to the other side, and we end up with 0 equals negative 5t squared plus 14t plus 3 minus 3. And those cancel out. That works out nicely. So now we're left with negative 5t squared plus 14t. And the way we factor this is to common factor. So we're going to divide out that negative 5t. And what we're left with is t minus 2.8. So now, to solve for the variable of t, we have them each equal to 0. We'll have negative 5t equals 0 and t minus 2.8 equals 0. And we will now isolate for the variable of t. We have t equals 0, which we don't really care about, and t equals 2.8. The t equals 0, when t equals 0, that makes sense because we know that it had initial height of 3 feet. So now, when this ball comes back down and hits 3 feet again, it happens 2.8 seconds later.